Hopefully the last two videos, which were about terminology, were fairly easy and straightforward, even if you weren't sure why we were naming things the way we were naming them. This is more complicated, confusing, and important, and it's one of those things that you have to be extremely good at and are going to be using all the time. So if you need to rewatch segments of this video, or if you need to pause and rewind just to make things make as much sense as possible, I would say it is well worth the time, and it will serve you well in the future. So you know how to multiply something like that. You distribute it in, and you do each multiplication. So 3x times x is 3x times x is x squared, minus 3 times 5 is 15, and the x just sits there. So that part of it is fairly straightforward. Now, the problem comes in is if the number is in front, multiplying, what happens if instead I have something like that? And the thing that you wish deep down inside is that it could be the same. You want this. And you want the answer to be x squared plus 5 squared. And I am very, very sorry to tell you that the universe does not work like that. If we could have that as a rule, we would. But it doesn't work. And I'll give you an example. Let's take 4 plus 5 squared. Okay? Now, we know, just from doing BEDMAS, 4 plus 5 is 9, 9 squared is 81. That's fine. But if I do it this way, 4 squared plus 5 squared, 4 squared is 16, 5 squared is 25, and if I add these two together, I get 41. 41, as numbers go, is really far away from 81. So whatever is going on, that is not a rule I can use. Doing this is not a valid shortcut. By doing that, you are guaranteeing that whatever answer you get will be wrong. So all of this is bad. And I will try and show you why using the example of 4 by 5. So what I will do is draw a rectangle that is 1, 2, 3, 4 squares plus 1, 2, 3, 4, 5 squares. And to square it, I'm going to make a square. So 1, 2, 3, 4 squares, 1, 2, 3, 4, 5 squares, and then finish off the rest of the square, and hopefully it looks halfway decent. Okay? So now, when I multiply, this is, let's put a little 4 there. This is 4, and this is 5, and this is 4, and this is 5. Okay? So when I do 4 plus 5, 9 squared, I am doing 9 times 9, and I'm getting all 81 of the squares in this picture. If I do the shortcut, I am only getting 4 times 4 plus 5 times 5, and all of these squares are missing. Okay? So how do we do that right, even if we're going to have variables inside? So I will show you the explanation. However, it's marked in the chapters. If you don't want the explanation, you just want the rule that you're actually going to use, which is a shortcut and it's faster, you can skip ahead to the appropriate point. So here is, let's make ourselves up an example. We're going to do x plus 2, and here we're going to do x minus 4. Okay? And this is what happens when you encounter something new in math and you work your way through it. We have to make sure that when we come up with new rules, they have to work with all of the old rules. Otherwise, I would get two ways of doing things that get two different answers and no one would be right. So what I say to myself is, if this first one was just a monomial, so say it was x or 5 or 3x, I would know what to do. right? It would be like this one. So I'm going to pretend for a moment that this is just a monomial, and I'm going to represent my monomial with a blue square. Like that. And I would distribute like that, which means I would have x times a blue square minus 4 times whatever the blue square was, right? Just like that. But I know that the blue square is really x plus 2. So this is x times x plus 2. And this is minus 4x plus 2. And now this is just a long distributive property question. I go there, there. So this is x squared plus 2x. Minus 4 times x is minus 4x. Minus 4 times plus 2 is minus 8. Look in the middle, I have two like terms that I can collect. Plus 2 minus 4 is minus 2x minus 8. Okay, so that is how I would do it, except you will notice that this is an awfully long number of steps, and I had to do something silly, which is I had to put a blue square in there. So this took me 1, 2, 3, 4, 5 steps to get the answer. And I can do a little bit better. Basically what I want to do is I want to get these 4 multiplications right away. So let me take, this is now the real version that everybody uses. X plus, is it? X plus 2, x minus 4. Okay? And here is how it works. So these lines go from one term to the other 2, and these lines go from one term to the other 2. So I can recreate all of those lines, and they look like this. I go one from here to here, one from here to here, one from here to here, one from here to here. So every single term has a set of distributive property lines that go to every term in the other bracket. So this one has 1 and it goes to 1 and 2. There's another term and it goes to 1 and 2. I drew 4 lines. I have to do 4 multiplications. X times x is x squared. X times minus 4 is minus 4x. 2 times x is plus 2x. Plus 2 times minus 4 is minus 8. So what I did, and this is a shortcut. So whenever you have shortcuts, we have traded something which makes sense for something which is faster and easier to do. And it's up to you whether or not you can live with that, but this is what most people get into the hang of. So if you'll notice, this line has the same 4 things as this line, which means now I can go collect like terms, my final answer, like that. So all I'm going to do is 3 more examples just like this back to back. So x minus 4, x plus 6. From each term in the first one, I draw an arrow to the others. That I drew 4 arrows, so I have to do 4 multiplications. X times x is x squared, x times 6 is plus 6x, minus 4 times x is minus 4x, and minus 4 times 6 is minus 24. It's not uncommon at all to have like terms showing up in there somewhere. And so this is x squared, 6 minus 4 is 2. Like that. Okay. Let's make it a little bit harder. So let's do 2x minus 3, 5x plus 1. Same thing. From the first term to the others. From the second term to the others. 4 lines, 4 multiplications. Now, if I was good at multiplication, this is still easy. If I was kind of iffy on multiplication, now I'm going to have to really slow down and do each one of these multiplications carefully. So 2x times 5x is 2 times 5, 10, x times x, x squared. 2x times 1 is plus 2x. Minus 3 times 5x is minus 3 times 5, minus 15, and the x just sits there. And minus 3 times plus 1 is minus 3. Again, like terms, very common. And if you always draw the arrows in the same way and you always do your multiplication in the same order, then your like terms will always show up in the same place. So you can really get into a rhythm and get into a habit, and you'll find it's not that difficult. So this is 10x squared plus 2 minus 15 is minus 13x minus 3, like that. Okay, now what about the question that we had at the very beginning, which was x plus 2 squared? Well, the right way to do this is to remember what squared means. Squared means have the thing and have the thing a second time and multiply in between. So now that I've written it out the long way, now I can see, oh, from there, 1, 2, from there, 1, 2. That's good. So now x times x, x squared, x times 2 is plus 2x, 2 times x is plus 2x, and 2 times 2 is plus 4. There are like terms in the middle. Like that. So it's fairly straightforward, but you do always, always, always have to remember that this is not the same as so just remember that is not a rule. Now what happens if I want to do maybe instead of binomials, trinomials? Okay, well, how about that? Well, the rule is still the same. So I go from each term to each of the others. So from this x, I need 1 to there, 1 to there, 1 to there. From this y, I need 1 to there, 1 to there, 1 to there. From this 3, I need 1 to there, 1 to there, 1 to there. And even with the colors, you'll see this is getting really confusing really fast. But I know that I have to do 9 multiplications, so let's see if we can just sort of speed up through this. If you want to pause the video and see if you can do it all on your own, but to give you a sense of what it looks like. Just like that. And now I have to do a little bit more work to find my like terms. So there's only one thing with an x squared, so that can go there. And maybe with a lot of these things, oh, by the way, I can double check and make sure I drew 9 lines. There should be 1, 2, 3, 4, 5, 6, 7, 8, 9 things there, which is good. And I might even want to do a little, so I got this one. All right, maybe then I will do this plus 2y squared. I got that one. Okay, there are a couple that have xy, so plus 2 and plus 1, so that is plus 3xy. There's 2 that have x's, so minus x and plus x, that's plus 2x. There are 2 that have just y, minus y and 6y, so plus 5y. And then the only thing left at the very end is this minus 3, which just stays minus 3. So that was really long and boring and difficult, but if I was writing clearly, it wasn't hard. The only thing left is, what happens if I have 3 things? You know what, we've been using x a lot. Let's use a different letter. Like that. Okay. Now, you have to remember, if this was 3 numbers multiplied together, how would I do it? So what if this was 2 times 6 times 10? What would I do? Well, first I would do 2 times 6 is 12 times 10, and then 12 times 2 is 120. But I would also have the option, if I did 2 times 10 first is 20 times 6 is 120. I could also do 6 times 10 first, which is 60, times 2 is 120. So I multiply them, 2 of them together, and then multiply that answer by the third. That is the same for this one, where I'm going to multiply 2 of them together, and I have a choice what order I do them in. I think left to right is probably the easiest. So like that. There. But when I'm done at the end, I'm still going to have to multiply by this third one. Okay, but this one is a times a squared, plus a minus 3a minus 3. And I would rather collect these like terms than have 4 things to have lines coming out of. Okay, and then now, because of the way this is written, if I had them coming out this way, I would have lines coming out a lot of places. What I would rather do to make this easier on myself, and I'm allowed to do this because 2 numbers multiplied together, the order doesn't matter, 6 times 7 and 7 times 6 is the same number, I will put this first. And so now I have a more clean picture drawing the arrows. Now we've already done a long example, so I'm going to rush through this, and you can stay to the end and watch or not. But it's going to be 6 multiplications, which means I will finish with 6 terms, and then I will look to see if I have like terms at the end, and I will scrunch them all together. So if you want to do it on your own and watch to see if we get the same answer, that's great. Otherwise, take the lesson here, and good luck with your math homework.